Hello and welcome back to the shop. And today we're going to get working on that gearhobber. So today we're going to be concerning ourselves with part number GH-11 and GH-13. And as you can see, they're both banjos. They're machined relatively the same exact way with just one minor difference. So I'm only going to film making one of these. Otherwise the steps are all the same. Why don't we hop over to the bench. I'll show you one little problem with the measurements on this on the plans and where I found them and how I figured out exactly what that measurement is, and the one small difference between making this and making this. Okay, so this video is going to be concerned in making part number GH-13 and GH-11. So here's GH-13 that I've already made, and here's GH-11 which I haven't started yet. Now you can see they're pretty much the same relative shape. There are two major differences here though. Number one, I want to show you exactly how these fit on the machine, because in these plans here, this inside diameter of GH-13 is not specified. Now where this lives is clamped onto the outside ring here of part number GH-14, which will be the infeed with hand wheel on it. So the actual inside diameter of GH-13 here needs to be 1.25 inches for it to clamp onto it. GH-11 here, alright, is specified as a radius at 0.938, and where that lives is clamped onto this outer ring of the Hobber spindle housing, and that's 1.875, and if you double the radius that they give you at 0.938, that's 1.876, so that is correct. Now they will be made almost exactly the same way. The only difference is on GH-11 here, instead of taking a cut off of the entire piece, you can see that this piece here is inset. So I basically just have to, on the mill, flatten this side in this side to be able to put it in the lathe and bore it. You'll understand more what I talk about when you actually see the rest of the video. But otherwise, these two parts are made exactly the same in the same step. So I'm not going to film both of them. All right, I'm just going to film doing this one here, but they're made exactly the same way, with the one difference being that this face and this face are the only two that you need to just deck off in the mill. Okay. Okay, so I got that part is 3-pointed in the vise here, and all I want to do is create two parallel surfaces so that when I put this in the 4-jaw chuck on my lathe, I can slap one of these sides right up against the chuck and know that this is nice and flat, and that bore will be perpendicular to anything else we need to do with this. So I'm just going to take a skim cut on both sides. If you have a fly cutter, you can do it with that. This cast iron scale here is a little hard. I don't have a carbide bit that will fit any of the fly cutters I have, and my fly cutter is too small anyway. So I'm just going to use this. This is an older, and it's sharp, but it's older and a little bit ugly. So if I dull this end mill, I'm not going to be sad. Plus, it's, I think, the largest diameter that I own pretty much. So we're just going to take and flatten both sides. Alright, so there's the finished product. Pretty good. We hit a little bit of a hard spot right around here and right in this area here, but we were able to get through it. That's cleaned up enough to be able to get a nice flat surface on. We're going to flip it around and just do the same thing with the opposite side. Clean up all the cast iron dust, and I'll get that other side taken care of. Okay, so now we got to put an 1¼ inch hole in here, and I basically just line that up by using my tailstock, the center of my tailstock, and then I just made a scribe line with the tool and kind of just eyeballed it. So it's a rough casting. It's not going to be perfect. Basically, just as long as these feet here are flat up against. Now, they are flat up against. You can make sure of that just by getting a little mallet here. Make sure we're flat up against. And we're just going to go slow with this. So okay, should be tracking pretty good here. 1 inch 45. Should be around 150. That's actually 250 on the nose, pretty much. Beautiful. I'll go for that. Okay, so now we're going to make the 2 slots in this banjo here, and according to plans here, the way they have this set up, they're going from the center of the end mill. Alright, so this is 2.374 and 3.938 from end to end, and 0.374 is the width, so it's 3/8. It's for a 3/8 bolt basically. So what we're going to do is just add 3/8 to this, which would be the radius of the tool bit here, the radius of the tool bit here, which will give me the full width of the slot from end to end. Same thing here. Scribe lines down the middle, and we're just going to use scribe marks to get this lined up because it's not really critical. Basically, just as long as there's a slot here and a slot here, it's not supremely critical, because what this is going to hold is a gear train that you'll be able to slide down just like the banjo on your lathe. So what we got to do now is just set this up on the mill to be able to slot these. Okay, so it's going to be really hard to hold this in the vise and get that center line here that I scribed on here in line with my mill travel. So what we're going to do is use a stop in the T-slot. Now you can use anything. You can use a piece of 5/8 tool steel in there to use as a stop. Anything you want. What I'm going to use are these, and these are called coins, Q-U-O-I-N-S. They were for typesetting, and basically the lead typeset will be put in, and these will be like two little ramps and basically a wedge, and they would push everything in line and hold them in place. Same idea as like an adjustable parallel. And that's what we're going to do, is just we're going to set this in our T-slot here, use this little key, give it a little turn, and those suckers are locked in. So now we can push this there, and we're pretty much sure that we're relatively straight. Granted, I am going against a cast edge, so it's not going to be perfect, but it doesn't really matter. Again, these are just adjustments. So what we need to do now, though, is we do need to raise this up so that we don't drill into our table. So what we're going to do is, I have some 1/4" tool steel here, and these are just 1/4" tool bits. I measured them all. They're all within 1/1000th of each other, and we're just going to use those to hold this up off of our bed. And now we can push right up against that, and we can clamp this down. Alright, I had to move over to this side just because of a clearance issue on between my workbench and the mill. So what we're going to do right now is just have a wiggler in here. I'm going to pick up the center of that scribe line. So I'm going to turn the mill on, and we're just going to straighten this guy out. Just like that. And we're just going to eyeball and pick up that center line. Okay, we follow and track that pretty good. So I'm going to lock my table off at that. And shut the mill down, and we're going to put in a 3/8 roughing end mill. This is a Niagara coated one, so we're going to go ahead and do that. Okay, so I'm going to start her up. Basically gonna go from there to there. There's 100,000. there's the slot. And basically we're just going to repeat the process on that side. Okay, so we're getting into the last two operations, and basically what we need to do is we need to drill and tap this here for a 1/4 screw and clearance the top and split it. Now I have this in one of those, like, I don't know what they're labeled as, precision vices, grinding vices. These guys, the ones that have the little rod that goes in the hole with the little yoke on it. Apparently this one I paid $39.95 for. Or $39.50 actually. So hey, what are you gonna do? So I have that in my main vise hanging off. I have down here, there's a jack just holding this up, and I put this in there using a square. And what we're gonna do now is we're just gonna look and see how even that is just by eye. And that looks pretty good, actually. That looks pretty straight. If I drill straight through like that, that looks good. So what I want to do right now is make a nice flat surface on top of here. So I still have that 3/8 end mill. All I'm going to do is just flatten this top so that my drill doesn't wander when I go and drill it. Okay, got that pretty much lined up in the middle. We're just going to drill straight through it. And there she is. So let me get a 1/4 chap. Okay, I set 0 on my DRO. It's going to come off and eyeball just below center. Right about there. And we'll set our depth stop. It's going to scribe a line right where I drill in, so I know where to slit with my slitting saw. So now, here's my clearance. My screw. Now we're going to set up to slit this. Okay, so this is set halfway here, and now what we're going to do is just slit this. So I have my mill in back gear, and we're just going to go slow and slit this sucker in half. And there we go. Okay, so just to show you guys how this works, this is the part that we made, and I got my screw in there, and it's loose. Just like any other banjo, this is a piece of 1.25 inches, and if it's on there, and you can see, we can spin it around and adjust it to wherever we need to get a correct gear mesh. And then when we give this clamping bolt a little snug, now that locks it onto that shaft and doesn't allow it to move. So, hope you guys enjoyed this project, and we'll see you on the next one.